Hello friends, welcome back to a new course of Kubernetes. In our last session, we are done with the Docker. Thoroughly, we have completed our Docker course. So, in the last second session of Docker, we have gone through about the Docker Swarm. So Docker Swarm, this is nothing but it is an orchestration tool that is used for deployment purpose, and it works on cluster environment. But in industry, most of the companies are using Kubernetes rather than Docker Swarm. You can use Docker Swarm, it will whatever you want you can achieve with that one also, but Kubernetes is more advanced than Docker Swarm, and companies 99.9% Kubernetes are using. So this is another powerful container management or container orchestration tool that can be used to manage and scale the container. So now we will start our journey with Kubernetes, and we will not start any other course in between. We will one by one we will take sessions and we will complete this one first. So please be with us, keep supporting us, and because your support is very much important for us, so that we can also be delivered the best content, and this information is valuable for you as well as for me also, because we are working in an IT industry. So in IT industry, if we can share our knowledge, that will be more helpful for ours only, for me as well as for you. So in this mindset, we have a major role of keep supporting each other. So please keep supporting us, and have a happy journey. Okay, so we will start now Kubernetes. So this is the first session of Kubernetes, where we will see some introduction of Kubernetes. So Kubernetes is similar to Docker Swarm but more advanced. It's more advanced, and Kubernetes is the product of Google. Google is providing Kubernetes, and Kubernetes is container management or container orchestration tools, or you can say platform, and it is used to create, manage and scale the container. We have seen in our Docker also, like how we can create the container, how we can manage the container, how we can scale the container. We have seen all already, but Kubernetes is more powerful, and the industry is using this only, heavily using this one. So that's why we need to learn this also. that is more valuable in your technical skills. So Kubernetes is nothing but just one line is explaining more about the Kubernetes. It is a container management or container orchestration tool or platform. It is used to manage, it is used to create, manage and scale the container. Okay. Kubernetes, also known as K8s. K8s. K8 means K stands for Kubernetes, and between K, the first character of Kubernetes K and the last character S, between these 8 letters are there. Sorry, 8 characters are there. 8 characters are there. U, B, E, R, N, T, E, S. So how many? 2, 3, 4, 5, 6, 7, 8. So between 8 characters are there. Between K and S, 8 characters are there. So that's why this is also known as K8s. K8s. So Kubernetes is a container management or container orchestration tool or platform. It is used to create, manage and scale the containers. It is also called K8s. It is an open source system for automating. It is an open source system for automating deployment, scaling and management of containerized application. Okay. Pod is very important in Kubernetes. So what is pod? One executable unit in Kubernetes is a pod, or you can say that smallest unit of executable component. What is executable component? In Docker, what is executable component? Container is the executable component in container. We can start, stop, run. So that is nothing but the smallest executable unit. But in case of Kubernetes, pod is the smallest unit of executable component. And what is pod definition? Pod is nothing but container, the container, same whatever we have seen in our Docker. Container plus extra code is equal to pod. Okay, so this is the introduction of Kubernetes. Next, see the diagram of Kubernetes architecture. So this is the Kubernetes architecture. How Kubernetes work internally, who will handle the request, who will create the pods, who will create the cluster, who will manage the cluster, to whom we will call. All this is depicted in this Kubernetes architecture. So first component is your kubectl. Some people pronounce this as kubectl. You can, whatever you want to call, you can call it, but I will call it kubectl. Cube, K-U-B-E, kubectl. Kubectl is nothing but, you can say that this is a client. Kubectl is nothing but it is a client, and this client can be used to interact with the Kubernetes, used to connect with Kubernetes cluster, you can say. Okay, the second, this is the one component. Second component, control plane or master component. What exactly control plane or master component does? This handle overall cluster. Overall cluster will be handled by control plane or master component. Internally in control plane or master component, some modules are there, like application controller, API server, that is a front end controller, K scheduler, we can say we can call it kube scheduler also, etcd. So this is the major components of a control plane. So who will handle the kubectl request? Who will handle the kubectl request? Kubectl request will be handled by API server. This API server or front end controller is nothing but your REST controller. This is nothing but your REST controller only. Okay. And from here it will be communicated with application controller, K scheduler. We will I'll explain after seeing this diagram. I will explain what is the use of etc, what is the use of application controller, what is K scheduler. Okay. Next important point is worker node. Worker node, like similar to Docker only. In Docker we can have a multiple worker node. Each worker node will have Docker, and that each node will be registered with Docker Swarm cluster. So similar to that only, each node will have kubectl, Docker plus kubectl, and each node will be registered with control plane or master component cluster. Similar in our Docker, from one node we are initializing Docker Swarm cluster using Docker Swarm init command. We are initializing Docker Swarm cluster we are initializing, and the worker node are joining that cluster using some command. The command will be printed on the terminal. That command we are copying and we are pasting in our virtual worker node terminal, and worker node is joining the cluster. So similar concept is in kubectl control plane or control plane. This is nothing but kube admin. So kube admin will be initializing the cluster. Once cluster is initialized, it will generate one token. Using that token command, worker node will join this cluster. Simple, same approach. We will see when we will do the installation. I will show you. And each node will have kubelet. What will kubelet will do? Kubelet job is to create the pod, manage the pod, all those jobs done by the kubelet. When I hit a command from control plane, please create a pod. So where the pod will be created? Pod can be created in any of the node. Currently in this diagram 2 nodes are there. You can have n number of nodes, 3, 4, 10, 50 nodes. Each node will have a kubelet. So this is the decision taken by your control plane in which node you are going to create the pod. So in whichever node the pod has to be created, in that node kubelet is running. That kubelet will create the pod in the worker node. So what will be the job of kubelet? Kubelet job is to create the a pod into the worker node. Okay. Fine. So this is the overall Kubernetes architecture. Next, so what is kubelet? We will describe each point now. What is kubectl? Kubectl is nothing but a command line interface used to send the query and to work on cluster. Simple. I want to work on my cluster, so I need some client. That client is nothing but kubectl. Okay. API server. This API server, what does it do? It is responsible to take the request from kubectl. Yes, you can see from this diagram. Kubectl sending request to whom? Kubectl sending request to API server only. So what is the job of API server? API server job is to take the request from kubectl and process. Listen the request from kubectl. Simple. This is the main job. Next, kube scheduler, k scheduler, we can call it k scheduler also. What does it do? See, simple. Kube scheduler select the best node for performing your task. You can say your task or performing the kubectl task. Like from kubectl I am writing a command, create pod with this name from this image. Simple. I am writing command like that, please create a pod of this name from this image. So where that pod has to be created. Pod can be created in any of the worker node. So this is the duty of k scheduler, to selecting the best node among the worker node. So this is the job of k scheduler. K scheduler select the best node to perform the task. Okay, or you can say perform the kubectl task. Okay. Next, application controller. What is the job of application controller then? Application controller execute the task on cluster. Example, creating pod. Now who will execute the job? Actual job will be executed by kubelet only. Kubelet only will create the pod. But who will instruct? K scheduler will pick the node, but who will instruct to create the pod? Application controller. Okay, so application controller execute the task on cluster, creating pod, something like that. etc, that is no SQL database, will maintain one database. etcd means database. So no SQL database, this is a no SQL database, store all the detail of cluster and its nodes. Suppose how many nodes are joining this cluster, where all this data will be stored. In some database it will be stored, so that database is nothing but your etcd. If you want to get the list of pods, how many pods are running in the kubectl cluster, in Kubernetes cluster, I want to get the information how many pods are created in Kubernetes cluster. So where this all the detail is stored, the details is available under etcd, under this database. And suppose I want to know how many nodes have joined the cluster, so that detail will be in etcd. I want to get the detail how many containers are running in the cluster, across the cluster, across the nodes, how many containers are running. So these all details will be inside etcd. Okay, fine. Kubelet, what is the kubelet job then? Responsible for container management. Example, pulling image, creating container, managing container. In our Docker, who is doing this job? Docker itself is doing this job. In this one, they have simplified the process. They have dedicated one person who will do this job. So kubelet will do all this, pulling the image, creating a container, managing the container, deleting the container, restarting container. So all this job will done by the kubelet. But instead, in case of Docker engine is doing all this. Okay. Next, k proxy. What is k proxy? Where is k proxy? Yes, k proxy is there, or you can say q proxy. So container network rules and configuration to establish connection. So similar to Docker. In Docker we have a network. Who will create the network? Docker Swarm creating the network, Docker Stack creating its network, it is managing. But In case of Kubernetes, they have dedicated module for that one. Kproxy contains network rule and configuration to establish connection. You want to establish the connection between the cluster and node, or between the nodes also you want to, between the worker node you want to establish the connection, or between the cluster and a worker node you want to make the connection. So that will be done by kproxy. Contains network rule and configuration to establish connection. Okay, next is kubeadm. What is kubeadm? So far you see control plane master component is handling the overall Kubernetes cluster. You can say that control plane or master component. It is managing the overall cluster. But who is initializing this one? Who is creating this control plane or master component? Your kubeadm. To set up the production or multi-node cluster, kubeadm is used. At minikube like single node cluster to for practice purpose. If you want to practice in your local computer, or if you are working on AWS, you want to work on a single machine just for learning the commands, checking the flows, for that one minikube is there. So you can install minikube and you can work on that one. Okay, that is minikube. By default, control plane master component is not taking any workload. This is very important here. in case of Docker, if you see, Docker is your manager and two worker nodes were there. In our example, we have we had one manager node and two worker node 1, worker node 2. So whenever I was creating containers, so by default the Docker Swarm manager node also taking the loads. One or two container in manager node itself, it was creating the container was running in manager node also by default. But in case of Kubernetes, by default this manager node, this control plane master component node will not take any load. It will not take. The load will be given only to the worker node. This will be just doing its management job. Control plane or master or manager component is just managing the cluster. It's not taking any request load or load balancing. It is not doing. Okay, fine. But Docker Swarm by default takes the workload. Okay. By default, kproxy do not create network. Yes, kproxy is similar to the Docker networking. But by default, Docker is creating one bridge network with the name bridge itself. And in case of overlay network, it is automatically creating overlay network. And if you are using Docker stack, then you no need to create the network. It automatically creates its own and it will use. You cannot override that also. But in case of Kubernetes, by default, kproxy do not create any network. You have to create. Okay. So this is all about the architecture and the introduction of a Kubernetes. Okay. If you want to know more about it, I will show you this link once. You can go and you can read more about, but generally to get started this is more than enough. Here they have given some more overview, like Kubernetes is a portable extensible open source platform for managing containerized workload. Same thing it is telling, and server. The facilities both declarative and configuration and automation. It has a large, rapidly growing ecosystem. Kubernetes services, supports and tools are widely available. So some extra point it is telling, but the general the purpose of Kubernetes, whatever we have studied, that much here only. Okay, you can go more about it. Some glossary, like some terms if you want to get familiar, like what is the name of this term. So you can simply, this is just like a dictionary, shabdkosh. You can get uh, any you can say any word definition if you want to you can get it. Suppose if I say cluster, you don't know what is cluster. So cluster is nothing but a set of worker machine. How many worker machine? Suppose in our Docker swarm we have created a cluster of 3 nodes. There was one manager node and 2 worker node. So similarly, cluster is nothing but a set of worker machines called nodes, and that run containerized application. That is cluster only. Every cluster has at least one worker node, then only you can say it is a cluster. What is controller? What is daemon set? What is deployment? Like, we will study one by one. What is deployment? What is if you say, I have said here one word, pod. If you see here, pod. What is pod? One executable unit in Kubernetes, smallest unit of executable component is a pod. So that definition, if you want to get, you can get it here also. You have to search it. I think search for pod. Yeah, pods. So what is pod? The smallest deployable unit of computing that can be created and managed in Kubernetes. That is a pod. A pod, as a pod of wheels or a p pod, is a group of one or more containers. See, generally what will happen, pod will contain containers only. Pod will have containers only, but in case of Kubernetes, we don't have that concept pods. Just we have a containers, like it is a 10 container, 20 containers. But that container, if you want to group, how will you do it? If you want to group the containers, how will you do it? But in Kubernetes, you can group them using pods. Further also, you can divide them by using namespace, something like that. We'll see that later. Okay, a pod contains are always co-located and co-scheduled, run and shared context. So there's some more details, so you can get the details like that. Okay, fine. Okay, so this is the diagram, that same itself only. Let me show you properly. Yeah, this one only. So same whatever we have discussed the above. This diagram I have taken from the official website only. The above one I created, this one I created, and this one I have taken from that only. But it's same. Control plane is there. Worker 1, node 1, node 2 they have given, but you can call it worker 1, worker 2. And each will have a kube proxy and kubelet, and inside that one pod will be there. Pod 1, pod 2, pod 3. CRI is what? What is CRI? What is CRI? Container runtime interface. Like, container runtime interface will specification to manage the containers. Okay, that is CRI. Fine. So this diagram you can just revise once. Next, kubelet. Some more details about kubelet will be there. Kubelet, you can see kubelet is where is the kubelet? Kubelet is inside a worker node. Kubelet is there. See, this is kubelet. So kubelet manage the container, and the container can be created by any containerization tool. Now here one important thing is there, like Docker and Docker D. Docker is one containerization tool. Docker is a containerization tool. Docker D is also a containerization tool. CRO is a containerization tool. So any containerization tool you can use along with the Kubernetes, but we are specialized with Docker. We can use Docker. Any containerization tool, any open containerization initiative, OCI, you can call it, you can use. This is nothing but just a specification, similar to your Java specification, like JDBC. JDBC has given one specification. Who has implemented that one? The database vendor has implemented that one. So similarly, Kubernetes has given its own specification, and they have given name OCI. Any company who wants to implement that OCI, they can implement it, and you can easily integrate with the Kubernetes. Okay, and you know one thing, Kubernetes came after Docker. Docker came before. When Docker came in a market, at that time Kubernetes was not there. So how Kubernetes is supporting OCI? It is supported through Docker D. Or if you use Docker, then you have to use Docker shim. It will automatically use. Then you can use that also. Okay. That is OCI, Open Container Initiative. Okay. OCI is an open container initiative, is an open governance structure for the expression purpose for creating open industry standard around container format and runtime. You can see the container this OCI specification here. I'll show you the OCI specification. Open Container Initiative. Open Container Initiative is an open governance structure for expressing purpose and creating open industry standard around container format and runtime. Okay, some specifications. See, specification 1.0. You want to read, you can read it. So these specifications has to be implemented, then only it will be supported in your Kubernetes. Okay, but using Docker shim, Docker is supporting this one. Okay, fine. So kubelet provide CRI what? Container runtime interface. Kubelet provides CRI, container runtime interface. This is again specification to manage the container. Suppose I want to manage the container. You understand like that. You take the example of your Spring Data JP repository. So in Spring Data JP repository, are you defining any method? No, method are defined where? The methods are defined. The method are defined in the CRUD repository standard method. Now how that has to be implemented? On the basis of specifications only. So similarly, if kubelet wants to manage the container in the worker node, then this kubelet must have some specification standard, then only it can directly call that method and it can manage. So similarly, it is providing container runtime interface, CRI, and that is a specification to manage the container, so that the containerization tool can easily be plugged in with Kubernetes. Every containerization tool vendor must implement the CRI specification to support with Kubernetes. Docker is implementing the specification of OCI but not CRI, because Docker developed before to CRI specification. So that to support Docker with Kubernetes, Docker shim is provided by Kubernetes. Kubernetes itself is providing Docker shim. to support with Kubernetes, to support with the Docker, because Docker is very much used in industry. And the Docker shim component of Kubernetes allows to use Docker as Kubernetes container runtime. Kubernetes built in Docker shim component was removed in release 1.24. Later on, Docker D they are using internally. Kubelet also provide NRI network runtime interface. Everything they are providing interface, like for managing the container CRI, for managing the network NRI, for managing the container open container initiative OCI. Okay, so Kubelet also provide NRI network runtime interface. Every containerization tool vendor must implement the NRI specification to support the Kubernetes. Well, that's it. So this is the kubelet diagram. You can see, if you want to support any container open container initiative, you follow that specification. If you use Docker, then Docker shim is provided. Docker D CRI is implemented, so I think they are using Docker D now, that because Kubernetes team is not developing Docker shim in the upcoming versions, so directly they are using Docker D and CRI. Okay, that's it. Oh, fine. So this is all about the introduction of Kubernetes. In the next session we will see the setup and installation of Kubernetes. Okay, thank you and have a nice day.